some PowerPoint slides there. I'm going to just go through a couple of these on and off throughout the presentation for what I've prepared to present to you today. As we go through the session, if you would use the questions box to ask any questions that you think of as I go along here, type them in, and then at the end, Dave Sweet can read a couple of those, and I'll try and give you some responses to them. And also at the end, if people have questions, we'll try to take them live, mixed in with the questions that people have submitted during the presentation. So again, use that questions box. It's in that GoToMeeting panel. Type in your question and hit submit. So I thought I would start out today with a slide to try and reiterate the point. I was talking yesterday with John Gilligan about what we were going to present, and he suggested, it might not be a bad idea to kind of start it off with, well, why are you doing it anyway? And so I thought that was a pretty good way to kick it off. And so while we get bogged down in all kinds of details today about what Design for Assembly can do, and my plan today is to show you a bunch of the features that are in the software that you might not know exist, or you might not know how to use correctly, or verify whether you are in fact using them correctly. Let's not lose sight of the fact that the ultimate goal of Design for Assembly is that top bullet, right? We are attempting simplification. I think quite simply put, that's what we're trying to do. And it's achieved through part count reduction. And I've got a couple of bullets that follow that may seem counterintuitive, and again, this came from our conversation yesterday, and what I would refer you to for all the gory details of this is a great paper that was written by Brian Raposa, our research and development manager here, and presented at our conference last year. If you're interested in that, if you send us an email or ask us a question about it now, we can send you a copy of it at the end of the day, or during the day today at the end of the presentation. But his point was that while we go on and on talking about how assembly time really isn't important because it's never a significant portion of the cost of a product, that it is the thing that you should focus on if you want to do Design for Assembly and accomplish great things, because what we've seen is that if you focus on cost, which is sort of the natural focus, you end up doing, in a lot of cases, nothing more than cheapening your product. Well, if you're able to focus your efforts on assembly time reduction, then it leads you to a better result in that you are able to reduce the cost that comes along for the ride while you focus on the assembly labor time. But at the same time, you maintain all of the functionality. So you're not taking features and functions out of products to reduce cost. You're still going to have products that accomplish the end functions that you desire and provide the features your customers want, but you're going to achieve that at a lower cost by focusing on labor than by focusing on the cost of the individual parts. And again, if you want to read the details of that, please let us know, and we'll send you a copy of that paper. And so I thought in that vein I would reiterate to you the minimum part criteria questions, because I think it's a thing that even people who have been doing Design for Assembly for a long time sometimes don't understand or don't know how to apply correctly. And it really is the sort of heart of the Design for Assembly process. And so what I generally tell people when we're doing training classes here in our office is that that for everything you answer in a Design for Assembly analysis, so I'm talking about the handling issues, the size of the parts, the weights of the parts, the insertion difficulties, the symmetries, all of the Design for Assembly questions are for what you've got in front of you right now. But when you ask yourselves these minimum part criteria questions, we don't want to know about what you have in front of you right now. We want you to think to yourself, in some theoretical redesign of my product, does this part, and then ask yourself these minimum part criteria questions. So this is the point in the analysis process where you are thinking ahead to what a future iteration of this design might look like. And so the purpose of the minimum part criteria is written there. You can read it. That's what we're trying to accomplish. And while we're doing that, there's two things we want you to try and keep in mind. The first one is admittedly very difficult to do, and that's to not consider technical or economic limitations. We want you to approach these problems from the perspective of having all the time and all the money in the world to accomplish them, and then throttle that back later given the reality of the situation. And then the second bullet is a bit of a housekeeping thing. It says evaluate with respect to parts already assembled. And what that means is if you have your structure chart developed and you've got a product that has 10 parts that go together by taking 1 and then adding 2 through 10, if you're looking at parts, say 6, you're only going to consider its elimination or combination with respect to parts 5, 4, 3, 2, and 1. So everything further up the tree. We don't want you looking at parts 7, 8, 9, and 10 yet. We're going to get to those when we get to that point in the structure chart. So evaluate with respect to parts already assembled. So the screen in the software where we ask you the minimum part criteria questions looks like this. These are actually 2 separate boxes that you're presented with. The first one is titled Item Function. And the statement is, does the item have no function except to, and you have 3 choices, the default choice being that the item has another function. That button being pressed, or that selection being made, causes this second box to appear. And that is the minimum part criteria questions where we say item must be separate from all those items assembled because, and then you have 5 choices to make. Again, the default one being that no fundamental reason exists. So what's happening here, and it's a little bit subtle, is anytime you add a part to an analysis, we automatically assume that it's not required, right? Just by the defaults here, that it has some other function and no fundamental reason exists why it needs to be separate. You have to justify to us why that part needs to exist in your design by selecting one of these criteria. Now, it could be that based on your selection of the criteria, it still doesn't need to exist as a separate part. Selecting one of these 2 choices causes your part to be flagged as a candidate for elimination. Selecting one of those 4 choices causes your part to meet the theoretical minimum part count or become theoretically necessary. And this last choice here, again, flags your item as being a candidate for elimination. So let's talk about what they are a little bit. The first one is, I talk about them as 2 special cases of the minimum part criteria. That's probably an overstatement, but the first one is if something's sole function is to fasten or secure, then it's always considered to be a candidate for elimination. And the thinking is that some other integral fastening arrangement is always theoretically possible. So you can see here we're talking about covering a hole in this plate with this plate, 4 screws, 4 washers, and 4 nuts, or we could morph the design of this plate into one that had some integral fastening elements and accomplish the function of covering the hole in the plate without all those things whose sole function is to fasten. So if it fastens or it secures, it's always considered to be a candidate for elimination. If it connects other items, it's also always considered to be a candidate for elimination. And connectors are these light blue things here. And I'm calling them things because they might be wires carrying electricity from point A to point B. They might be tubes or pipes carrying fluid from point A to point B. They may be links carrying force from point A to point B. Any kind of connection between 2 points, in theory, is a candidate for elimination because I could rearrange the structure of the product, moving point A to point B or point B to point A, and eliminate the need for that connection. So if it fastens or secures, or if it connects, it's automatically considered to be a candidate for elimination. If neither one of those things are true, then you say item has other function, and then we say to you, well, is it the base part in the assembly? That's the first one of those minimum part criteria questions. That's only true once. So the first part in a subassembly, unless it's the first item in your main assembly, it does not meet the minimum part criteria for being the base part. There is maybe a simpler way to say it is there isn't a base part of a subassembly from a minimum part criteria perspective. You have to ask yourself, with respect to everything above and outside that subassembly, does this part have to be, and then ask yourself these questions. So you should only have one base part in an assembly. And the thinking there, that last bullet, is that in theory, all of the parts that you add to the base could be combined back with the base. So you have to have a minimum part count of at least 1, and the thing that meets that fundamental criteria is the base part in the assembly. If it's not the base part, then we say, with respect to, again, everything higher up the tree, does this part have to move? And so here we're looking at that piston in that assembly base. The piston has to slide up and down in that assembly base. I can't have them be made of the same part, and experience that gross relative movement with respect to one another. So for reasons of movement, those parts need to be necessarily separate. Does it have to be made of a different material? And we're talking about fundamental material property reasons here, like electrical conductivity or light permeability. And so here we're showing that the sensor has to be made of a different material from the base. So in other words, if all the parts you've added to your product so far have been insulators, and now you're adding a part that has to conduct electricity, I can't have them be made out of the same part and experience that different electrical property. So for some fundamental material property reason, it needs to be made of a different material. And then the final criteria is termed assembly of necessary items. And so if we were to look at this cover, and we asked ourselves the criteria, well, it's not the base part in the assembly. It doesn't have to be made of a different material. In fact, it's the same material here as the base. It doesn't move with respect to any of these parts during the function of the product. However, if I were to combine it with the base, it would prevent me from getting the spring and the piston inside. And so we say the cover has to be separate for reasons of assembly. In other words, you can't put the cover on the box before you put the stuff inside it. So answering those questions is the key to the design for assembly analysis process. And as best you can, try to answer them literally. And I think an important point to convey is just because you can't think of how you would redesign your product not to have a particular part in it because it doesn't meet the criteria, it doesn't mean that you have to pick one of the ones that makes it meet the criteria. It means that you haven't thought of it yet, right? So DFA minimum part counts are generally low compared to the number of parts in a product, and we'll see that in the example that I have put together for you here in a little bit. So hopefully that was a good overview for some of you and helped understand a little bit more what we're trying to get you to accomplish when we ask you those minimum part criteria questions. Again, it is the key to the design for assembly analysis process. So I've brought up DFA here. You can see it on the screen, and it ought to look familiar to you. This is the motor example that you've probably seen in a bunch of our literature and some of our sample files and examples and so on. I'm going to use this to illustrate some of the things that that we have in here as additional features. One of the things that I wanted to touch on right away, and it was sent in by a couple of different people when you register for the webinar, is comments like the times between DFA 9 and DFA 10 seem to have changed. Why is that? And so there's a very simple reason for that. There's a simple answer to your question. And that is it's because of this set of dimensions right here. So DFA versions prior to DFA 10 used to assume that parts were put together on a bench by an assembly worker, and we had to make selections about distances that were required to acquire parts and tools. And we had talked to our users and feedback that we'd gotten from people and work that we'd done with people, and what we concluded was that in many cases, those distances that you have to move to get parts and tools can become significant in terms of the predictions of assembly time. But at the early stages of the development of a product, the design team has no idea whether a part is going to be 3 to 6 feet or 9 to 12 feet away from the assembly worker. And if you want a good representation of what the assembly time is going to be, then you would need to know that. And so we had some research and did some additional work to now make predictions of what the assembly area layout would look like based on the envelope dimensions of the finished assembly. And then we make predictions about how far away the parts are going to be based on the size and weights of the parts that you are adding to the process. And so let me jump back to PowerPoint for a second, and I'll show you a couple more slides here to kind of illustrate this point. So what happens, and again, you don't need to know this, the software handles it for you internally, but we define a large assembly as one whose maximum dimension is greater than 15 inches, and we define a large item as one whose maximum dimension is greater than 10 inches. So as a result of those two definitions, you can have four scenarios, right? You can have small assemblies made up of small items, large assemblies made up of large items, large assemblies made up of small items, and then the one that throws everybody for a loop is this second one, small assemblies made up of large items. An example of that is a 6 by 6 by 6 box that has 8 feet of fiber optic cable coiled up inside of it. That is a large item inside a small assembly. So what you do is you tell us the envelope dimensions for the assembly, and that then, let's say, virtually puts us in one of three modes. So for small assemblies, we're going to make the assumption that they're still being put together on a bench, and that items then are pretty much within easy reach of the assembly worker, and nothing would be different than what had happened in prior versions of our software. That's probably not an entirely true statement, but let's pretend that it is for now. As things start to get bigger, so in this case, you can see here that if an assembly contains several items that weigh more than 5 pounds or are over 10 inches in size, then bench assembly is no longer assumed. In this case, provided that the largest item is less than 35 inches and no item weighs more than 30 pounds, we assume this modular assembly center layout is used for the assembly of the product. And then the third case is for even larger assemblies, and this is for assembly sizes greater than 35 inches. We assume that some custom assembly area layout is used, and parts and the layout of the station is defined to be bigger, and therefore parts and tools and things like that are going to be further away from the assembly worker. So what keys that to happen, or sets that in motion, if you will, are these assembly envelope dimensions. And so, I've worked with a lot of people who come in here and they say, oh, our predictions of assembly time aren't matching. And they show me a file they've worked on, and these values are still all 1, 1, and 1, which are the defaults. And so you're trying to tell our software that you're putting together an assembly whose envelope dimensions are 1 by 1 by 1, and it has thrown off what the assumption is about the assembly area layout and the acquisition of parts and tools associated with that. So a very important part of doing a design for assembly analysis is supplying those finished dimensions of the envelope of the assembly of the product. And so just to show you, here you can see I have an assembly time of 190 seconds for this motor. And my envelope dimensions are here. If I make this 35 inches, now this obviously is made up because it's not that big, but just to show you what happens when I click off that field, my time changes by a significant amount in this case, because now it's assuming that parts are further away and that the layout of the assembly station is going to be much different. So for those of you that had submitted those questions about why your times are different, that's likely a big portion of what's taking place. Now, by the same token, the same thing happens at the part level. So if I click on a part here, you'll see we're asking you to classify the weight into one of three buckets and supply us the dimensions into one of three buckets. Now, that does two things. It changes the questions on the screen because we're no longer asking you things that don't seem to be appropriate. So if this part is 36 inches long, we're not going to ask you whether you need to use one hand with a grasping tool to manipulate it. In other words, I'm not going to use tweezers to pick that part up. So if I put in 36 inches here and I move off this field, you'll see the time will go up and these questions will change as a result of that change in length. The same thing happens with the weight. So as I select different weights, the times are changing and the questions that I'm being asked are changing. So the envelope dimensions of the assembly are very important. The weight and the envelope dimensions of the parts are also very important to classify correctly in your assembly analysis. Someone else had submitted a question asking about what about unpacking times and tool fetching times? And I believe their statement was that those things had gone away since we implemented version 10. And so certainly the part and tool acquisition times have gone away. They are now being estimated for you automatically based on, again, the envelope dimensions of the assembly and the size and weights of the parts. Unpackaging takes place for large parts. And so you see here when I've got this dimension at 36 inches, it says item requires unpackaging. And if I select that, the software adds some time to my process time for unpacking that part. Now, if you want to know what's going on behind the scenes, how we estimate that time, if you click the choice and then click the help, the software gives you a description here of how those times are being estimated for unpacking parts, and it has to do with whether they're long and narrow or rectangular, and you can read the definition of that later if you were interested in that question. So for large parts, you get to make the selection of requiring unpacking or not, and it will make appropriate choices for you based on those selections. So the second thing I wanted to show you, and this was available in prior versions of DFA. I'm not sure if people are aware of it in this version, but in the analysis menu, we have the ability to define custom user fields. And so here I can define a couple of custom user fields. So I can add one here, and I'm going to call this first one supplier name. And then on the right-hand side, I'm going to tell it, these are my choices. I can have a text box, a checkbox, a date, or a list. So I'm going to make this text. And then I get to choose whether it's available for parts, operations, subs, analyzed and not, and then DFA or DFMA mode. So supplier name maybe isn't going to be available for an operation. Then I'm going to add another one, and I'm going to call this delivery date. Just to show you a couple of different types here, I'm going to pick this as a date choice, and again, that won't be available for operations. And then let's add something different. We'll say approved supplier, question mark, and then I'm going to make that a checkbox. So that's going to be a yes or no, and again, not available for operations. Now, if I want, I can copy them from here. So see these two tabs at the top, one says current analysis, one says default for new. So right now, these would only show up in this file. If I copy this supplier name and I go to the default for new and I paste it, now every analysis file that I do will have supplier name as a field in it. Let me take delivery date as well, and I'll copy that and paste it into here. So now I've got those set. And if I say OK, what you'll see is I get an extra set of information now. If I go to my motor base, over here I've got this custom user field information. And you can see I can put in here a supplier name, and then I can choose a delivery date if I want to from a calendar. Maybe we're going to get that on March 1st. And then I can check here whether or not they're an approved supplier. And this could be, anything and everything that you might want to keep track of along with your assembly analysis. You can have as many of those as you want, and you saw from the list there I could have numbers, I could have drop-down things where I could choose, small, medium, or large, or high risk, low risk, medium risk design in the design, things like that, whatever you might want to keep track of. So those are custom user fields. A new thing that we added in DFA 10 are called functional groupings. And again, that's from the analysis menu here. You can say define function groups. Now, I've gone ahead and done that for this analysis. And so you bring up this box that says define function groups, and you type in the function groups you want to define. So I've got motor movement, sensing, and motor protection as my 3 function groups here. And what this allows you to do is assign parts in your assembly to different functional groupings that you've created, and then you can generate reports based on those functional groupings. So if I wanted to add another one here, I could hit enter and I could call this Nick, right? I could create a functional grouping for whatever I want. So I'm going to delete that, so I'm back to what I started with. And where those show up then is if I click on the motor base, you can see here in this item information box, we have this function group drop down, and that's where I can pick which function group I want to assign that part to. So I can have none, I can have motor movement, motor sensing, or motor protection. So you can see the base here was added to my motor protection group. If I go to the motor, it's added to my motor movement group. The sensor is part of my sensing group. And so what this allows me to do is say, gee, how much money, how much time, how many parts are associated with functions that I've defined or functional groupings that I've defined within my product. And so I've gone ahead and done that and assigned parts within this to the function groups. And then I've also done that for the motor redesign. So these are also now assigned to the different function groups. And so if you go to the results menu and you select functional breakdown, you can see I have a choice of count, time, cost, total cost, or weight. So I'll pick total cost here. And then I can pick one analysis or I can compare analyses. So let me show you one analysis first. So if I say OK, the software is going to generate for me a graph that's going to show me how much cost is assigned to each of those function groups. So of my product cost $49.90, just over $30 is assigned to the motor protection group. Just over 15 and just over 3 associated with sensing. So I like to think of this as an interesting way to look at the cost of a product. If you have decided that certain features and functional groups maybe of your parts are important to your customers, then you would want to know that you were spending money on those things that were important and not on those things that weren't. So if, for example, motor protection was not something that your customers wanted to pay money for, you can see here that we're spending an awful lot of money protecting the motor. So what I can do is define those groups and then I can compare them with one another. So if I come back to the functional breakdown, I can look at my before and after, and I can see what the changes in cost are associated with those functional groups as I move from design A to design B. So instead of just looking at total cost, at assembly labor, at part counts and things like that, you can define these groups and see how much money am I spending in this area of my product and how has that changed as I look at that the evolution of the design throughout those different groups. So hopefully that's a feature that some of you can start to take advantage of if you didn't know that that was already something that was in the software that you could use. The other thing that we get asked fairly frequently is, can we import a CAD model? And there's two answers to that question. The first answer is not for what you want to do, and the second answer is yes. And so you can't import an assembly model to create a product structure. So DFA works with a bill of materials if you're trying to generate an assembly structure. It will work with, you can certainly attach a CAD model to a part and get the envelope dimensions and any geometry information that you might want to use if you were going to do a DFM analysis. And so I'm going to show you how to, if you go to the external menu, that's where both of those features are. So I can import a CAD model here if I want. Or I was going to step you through here quickly our bill of material import wizard. Again, I'm not sure how many of you have used that. So if I select bill of materials, it starts up our wizard where we want you to find a bill of materials. And so there's a sample one installed with your software in the DFMA directory. And it's in the data and samples folder, and it's called motor. And we can read in CSV files or we can read in text files. So I'll read in this CSV file. And that starts this import wizard where I only have a choice of a new import right now. At the end, I can save my template, and then I'll have a list of templates here that I can pick from so I don't have to go through the wizard every time. You can see here it's showing me my bill of materials down here at the bottom. If I select next, then I tell it what the column type specification is. It actually looks at the file and makes a pretty well-educated guess about what these selections ought to be. We want to ignore this header information, so we're going to start our import at row 2. And then here's where we do the work. We have to tell it which of these columns is going to go where in our DFA analysis. And so column 1 here is actually going to be the level. You'll see they're levels 1 and 2 to indicate to me subassembly values. 2 is going to be the name. 3 is going to be the repeat count. I'll put a couple more in here. 4 is going to be our part number. 5 is going to be the piece cost. And then what you'll see is in this bill of materials, we also have a supplier name. And so if I go to column 6 here, you'll also see that I can import into the custom user fields that I've developed. So if you develop those custom user fields ahead of time and they're defaults in new analyses, then you can select where you want that to go. So I'll put the supplier name in the supplier name custom user field. And when I click finish, the software imports that bill of materials for me. You can see it put it here on a new tab. and it created this structure. And if I click on one of these parts, you can see it's got a part number, a quantity, the custom user field has come in, and the cost of the part. So it's a much quicker way to go about building up the structure. If you have a bill of materials, you can then obviously manipulate the structure of the product and get parts in the right order and move them around and manipulate it to be reflective of an assembly sequence for the product. I clicked finish one step too quickly there. If I had clicked next to go to the final step, then that would allow me to save that template. And then when I go to import the next time, my bill of materials would have that information there, that template there, and I would just click that template and say finish, and it would just import. So if you're, column 6 is always your supplier name and column 3 is always your part number, you don't have to go through that set of steps every time. There's 2 more things I want to show you quickly, and then I'll get to taking some questions. The first one is another feature that we've added, and it's the ability to create tabular reports. So if you go to the results menu and you pick this tabular reports option, you can select the tabular report generator. And this brings up this report generator where we have an untitled one here, but I'm going to create a new one and I'll call it Nick's report. And what it allows you to do then is pick the things that you want to have on your worksheet. So I'm going to get name. I'm going to have, let's go piece part cost per product and minimum part criteria. And then I could also pick supplier name so again, my custom user fields are available here and I could put supplier name on there. So I've developed now a tabular report that has that information on it. And if I want, I can right click on these columns and I can sort them. So if I wanted my report to be in descending order of piece part cost per product, now it will resort that for me. Whoops, sorry. And it will show me that, let me reopen that file. And it would show me the information there that I had selected. And they would be shown in some descending order of total cost. So you can have as many columns as you want. You can sort based on individual columns. And let me add one back in here again. And I'll just pick name and piece part cost and whatever, function group. And if I say OK now, that's stored as a report template. And if I go to the results menu and I pick tabular reports, now Nick's report is there. And if I click it, it says which one do you want to see it for. And now it'll bring that up for me and show me that tabular report with the information on it that I had selected. You can create as many of those as you want, and they are stored now for your software. So if I bring up a different file, so I'll go into my documents samples directory, and I'll bring up that piston assembly. You guys have seen this one before. Here's this completed piston assembly. You'll see that that template is available here, and if I bring it up for this file, it'll have that information on it that I wanted in the other one. So you define a template and then it applies that to the different files that you want to look at. So that's how tabular reports work. And then the one other thing I wanted to show you is, I think, a pretty big time saver. And that is, it's fairly simple. You can, from the file menu, choose print. And it brings up a dialog box and says, well, what do you want to print? And you can select all of the graphs and reports for the different analysis tabs that you have within your file. So if I want the DFMA totals to include the tooling investment, and I want my functional breakdown by total cost, and the suggestions for redesign for the original motor, if I now say preview, it'll show me a report that has all of those things in one. So I don't have to go to the reports menu, pick the one that I want to see, and then print it, and then pick a new one and print it. I have all of these now laid out in this one report template, if you will. That's probably not the right term for it. And from here, I can do the file export. and I can export this information as a whole now to PDF, HTML, Excel, whatever I want to do with it. So I don't know how many people knew that was there. File, print, and then you can save yourself quite a bit of time by picking all of the things that you want and saying OK. So I know this is a lot of information coming at you quickly. I've made this one intentionally 45 minutes because I thought it would take me a while to get through it. Why don't I stop talking for a minute and open it up to any questions? I don't know if we want to take a live question or if people have been submitting questions as we go along, but Dave, why don't you either let me have a live one or read me one?
Okay, Nick, we have a couple of questions that have been submitted, so I'll pick a couple of those. The first one is just simply, does the term finished product mean the assembly or the packaged product?
Okay, thank you. Good question. Let me say this. If you want to ask a question live, you can raise your hand. There's a feature to do that, and then Dave will know to call on you. So should the envelope dimensions of the product include the product or the packaged product? And I guess my answer to that question is it depends on how far you're taking the assembly process. So if you're looking at only the assembly of the product, then these would be the envelope dimensions of the product. If the assembly process that you're laying out includes the packaging that you're doing, then I would say and that's done as part of that assembly process, then I would say you would want to include the packaging as part of the envelope dimensions of the product. Another question.
All right, we have another question here. How do you handle the situation where tooling is further away than the local work cell? Is it an added step?
So where tooling is further away than the local work cell. So you could handle that a couple of ways. I guess what I'd like to tell you is that based on our research, if you put in the envelope dimensions of the assembly and supply the weights and dimensions of the parts correctly, then we ought to get a fairly rough idea that should give you a pretty good number of how far away those parts and tools are going to be. Now, if it was a special case where there was some gauge where they had to walk to the other side of the factory to get it because there was only one of them, then you can do two things. You can either add an operation to capture that time, and my suggestion would be you say insert operation, and here I'd probably do something like adjustment of item by hand, and that just allows you to add a flat time. So I would say 45 seconds, and then you can rename that on the tree here to get special gauge, right? You could do that, and that would certainly account for the time. Or if you wanted to, you can go to the worksheet, and on the worksheet, you can edit the time. So I can edit the time here for the entry, whoops, this one, and I could say this was now 48.54, and it colors that in gold. And then what I would do is delete this, and then in my notes field, you'll see I could type in here a note that says time now includes time to get gauge. So either add an operation if you want to capture it separately, or edit the value on the worksheet. Or again, the time should be not too bad if it's not an extreme special case like the one I was just talking about. Hopefully that answers your question. Any other questions?
Okay, yeah, I think we have at least one more here. So the question is, for small parts, is the assumption that there is no unpackaging time, or does the software have some built in?
So there is no unpackaging time built in for small parts. If you were somehow getting small parts in individual plastic bags and you wanted to capture that time, then you would want to add an operation for unpackaging those items as part of this assembly process. And again, you could either create your own operations from the library. So you could go to library, pick operations, and you can add your own. Maybe I'll do a webinar on how to add operations in the future. That's a whole another discussion for right now. Or you could add one, the adjustment of item by hand, for example, call it unpackaging and say it takes 8 seconds. So you can get very detailed with it, creating your own operations, or you could take a stab at it just using default information that's available. Do we have another question?
We have a couple more that we'll probably take offline, Nick, because they're a little bit more in depth.
Okay.
But other than that, I think we're pretty much all set with the questions.
Okay. There are, then, if we're all set with the questions, I just want to show you two more things that I sort of left out because I thought I was going to run out of time. One is if you have taken the time to add those custom user fields, which mine for some reason are now gone, so let me add one back in. So I'll just add one called supplier name and say OK, and there it is now. On the worksheet, if you want to display that on the worksheet, you'll see it's not here. You have to right-click and then choose it. And that will add now supplier name as a column on the worksheet where I could input information or move the columns over and put them in the right order. So if you add custom user fields and you want to see them on the worksheet, right-click and then select the name of the custom user field and it will be displayed. If you want to turn it off, you can hide it. So I think if I right-click here now, you can see supplier name can come back and I can put it right there. And then the other thing, and let me exit this and then reopen it really quickly, is just so I have the right information in here. That I would encourage you all, and I don't know how many people are doing it, that when you do your design for assembly analysis and you're finished, as I am here, right? I've got 19 parts and 4 parts that meet the theoretical minimum. You're going to copy and paste the tab, and you're going to rename it, your redesign. Use this redesign button. It, I think, is underutilized by people, and I think it's very helpful. So you're ready to go about modeling your changes or thinking about your changes. Press this button that says redesign, and what happens is the software categorizes suggestions into one of 3 buckets: category 1, 2, and 3, and it highlights them. So these are the parts that are meeting, if you will, our category 1 suggestion. And so the bushing has been identified here as a part that's a candidate for elimination. And if I want, I can use this worksheet to model those changes. So if I were to combine the bushings with the base, well, that would allow me to delete those bushings. They're gone. And I could just rename this to the motor base / bushing. And that change has taken place, and the software has recalculated the time already in the background. I could then go on to fasteners. These are the parts whose sole function is to fasten, and think about how I could eliminate those. When I go to separate operations, you can see the operations are highlighted. Well, if I didn't have the bushings, I don't need the separate press fitting operation, so I could eliminate that. And then finally, this shows me all of the handling and insertion difficulties that have been identified and quantifies the total time penalty for me. So here, the fact that the motor is awkward, requires holding, and is not easy to align has 5 seconds of assembly time penalty assigned to it. If I add all of those up of my 190 whatever seconds, I've got 40 seconds almost of assembly time penalty that's being identified based on things that I could change in the design of the parts to facilitate ease of assembly and allow me to reduce quite a bit of assembly labor as a result of those changes. So use that redesign button, make those changes. If you want to, if one of the ideas is, well, I'm going to snap fit the end plate, the grommet. So you could click on the grommet, click the questions, change the securing method, and then go back to the redesign button. So there's, that back and forth is set up here to take place to be helpful for you. So those were 2 additional things that I just wanted to highlight that are there, kind of give you a real brief overview of how to use them. And certainly if you have any additional questions about these or any of the features that I've talked about today, don't hesitate to shoot us an email. You can get us at info@dfma.com, support@dfma.com, or you can email me directly, ndewhurst@dfma.com. So again, thank you for your time today. I'm a couple of minutes over, so I'll wrap it up here. Look for another one of these Q&As to be coming in a month or so, and if you have suggestions for topics, please go ahead and submit them, and we'll try and get to it at some point in the near future. Thank you for your attention, and enjoy the rest of your day.